This is Learning Target 8A Notes. So we're simplifying rational algebraic expressions with monomials and binomial factors. So example 1, we have 24 n to the fourth, that's a monomial, and the denominator, that's the numerator, and then the denominator is 36 n to the fifth. At this point, we actually have, in example 1, factors. 24 is a factor, n to the fourth is a factor, 36 is a factor, and n to the fifth is a factor. So we're going to look to simplify. 24/36 that's a fraction. You can divide numerator and denominator by anything that's in common, 2, 4, 6, 12. 12 is the biggest one. So you divide it by 12, you get 2. Divide the denominator, that's the numerator. Denominator by 12, you get 3. Now n to the fourth divided by n to the fifth. We have like bases, the n's. So you would subtract the exponents when you're dividing like bases. So you subtract the exponents. Typically you take where the biggest exponent is 5. 5 is bigger than 4. And then you bring the 4 down and you subtract them. So that'll be n to the first. So our numerator looks like we just have a 2 left over. Denominator we have a 3, n to the first, or just n. Example 2. Here we don't have monomials, so anytime you have a binomial or a trinomial numerator or denominator, we got to think factor first. So we got to factor it first. So we're looking at the numerator, m minus 4. Can we factor it? No. And the main reason why I know we can't, it's to the first power. That's a linear binomial. And there's no GCF. So the main thing is there's no GCF, and it's a linear binomial. You're not going to be able to factor it any further. In the denominator, we have 5m minus 20. Is there a GCF? Well, let's see here. Yeah, we can divide both terms by 5. So there is a GCF of 5, and we have m minus 4 left. And in m minus 4, that's a binomial. It's a linear binomial. We're not going to have anything else we can factor. So m minus 4 is the numerator. The denominator is 5 times m minus 4. At this point, we have it factored, the numerator factored as much as you can, the denominator factored as much as you can. And now we're looking at comparing our monomials and binomials. Well, our numerator only has this binomial, m minus 4, and our denominator, the factor m minus 4, that binomial, is also there. And when we're doing this, we're simplifying. M minus 4 divided by m minus 4, that's the exact same binomial. Really, it's m minus 4 divided by m minus 4, that's the same thing divided by itself, is 1. So in the end, the numerator is 1. The denominator has 5 times 1, which is 5. So our final answer is 1/5. Example 3. So we look to factor the numerator. Is there a GCF? We have 1, 6, 8, no, and there's no n on the 8, so no greatest common factor. But then we have, this is a trinomial, 3 terms, and it's a quadratic, so we should look at a times c. So 1 times 8 is 8, and you can do, since the a term is 1, we can actually kind of cut out a times c and just do what 2 numbers multiply to c that add up to b. So what 2 numbers multiply to 8 that add up to 6, that's 4 and 2, or 2 and 4. Those are your second terms of your binomials. And then we have n squared is n times n is n squared, and there's your factor. If you don't really like that, you can absolutely do the Punnett Square. It still would be 4 and 2 would be multiplied to 8. That'll add up to 6. You can certainly put those in quick. A term, C term, bottom right, 4n, 2n. Take out your greatest common factor of each row, each column, and you'd have n plus 4, n plus 2. So we already have that. In the denominator, again, I'm looking at, is there a greatest common factor? No. is A is 1. So we can do what two numbers? So I can just write kind of two parentheses, sets of parentheses that kind of would fit a binomial in there. And then we see it's a quadratic and it's a trinomial. That's going to most likely break down into two binomials. We have what two numbers multiply to -12, but add up to -4. This is a shortcut when A is 1. So that would be -6 and +2. That multiplies to -12 and adds up to -4. And n squared is n times n. But you can, if you don't like the shortcut, you want to do the Punnett Square, you're more than welcome to. At this point, we look at binomial factors have to line up with binomial factors. So I'm looking at n plus 4 in the numerator. Is there an n plus 4 in the denominator? It has to be exactly n plus 4. Binomials have to be exact. There is not. Then I'm going to look at n plus 2 in the numerator. There is an n plus 2 in the denominator. So when we simplify these, n plus 2 divided by n plus 2 is really going to be 1. And then left over in the denominator, we have an n minus 6. There is no n minus 6 in the numerator, so we cannot simplify that. So in the numerator, we have n plus 4 times 1 is n plus 4. We have 1 times n minus 6 is n minus 6. And there's your final answer. Last example. Really going to be the same concept as the others. Look at your numerator. Can we factor it? So you think GCF. Is there a GCF 2, 5, 12? No. X squared, X, and no X, so no. No GCF again. Unfortunately, the A is not 1, so there is no shortcut here. So we have to do A times C, what adds up to B. So two numbers that multiply to -24 that add up to -5. That should be -8 and 3. Do your Punnett Square. A term top left, C term bottom right. -8 and 3 does not matter the order. They have to add up to the B term, so X. Take out your greatest common factor to the bottom row, so -8x and -12 is going to be 4. Because the 8x is negative, it'll be a -4. Top row is X, first column is X, last column is 3. Because the 3x is positive, it'll be a +3. Oh wait, I messed up. It should be 2x squared, just 2x. So we have 2x plus 3 times x minus 4. In the denominator, we have the A term is 1. Is there a greatest common factor? No. I kind of glossed over that. There is no greatest common factor again. A term is 1, so we do what two numbers multiply to -4, the C. That will add up to B. Since A is 1 in this quadratic trinomial, we can do what two numbers multiply to C that add up to B, and that's going to be -4 and 1. You can switch those around if you want. X squared is X times X. And now we're going to look at, it's totally factored, the numerator and denominator, totally factored. We look at individual factors now. 2x plus 3. Is there a 2x plus 3 in the denominator? No. X minus 4 in the numerator. There is an x minus 4 in the denominator. So when we're simplifying those, x minus 4 divided by x minus 4, that's the same thing divided by itself, which is really 1. And then in the denominator, there's an x plus 1. There's no x plus 1 in the numerator, so we cannot simplify that. We have 2x plus 3 times 1 is 2x plus 3. 1 times x plus 1 is x plus 1. And there's a final answer. Come to class with any questions you have. Thanks for listening.